Welcome to the Deep Dive, where we sift through your sources, everything from ancient texts to the latest scientific reports, and pull out the key insights. Today, we're heading out on a pretty incredible journey. To the stars, actually. Our mission, if you will, is to trace humanity's, well, constant quest to reach beyond Earth. From those very first dreams, right up to the, frankly, audacious plans for maybe colonizing other worlds.
It really is fascinating, isn't it? How that basic human urge to look up, it's just been there for millennia. And we're not just talking rockets and, specific missions. It's the whole evolution of an idea, this collective ambition. It pushed us from just gazing at the sky to, well, actually touching it. Makes you ask, what basic human need does all this exploration really fulfill?
Exactly. And, you're going to find some surprising connections, like how ancient stargazers really did lay the groundwork for astronauts, and how science fiction, sometimes it wasn't just fiction, it actually helped pave the way for real science. So, yeah, buckle up for a trip that might just change how you see our little place in the cosmos. Okay, so where did it all kick off? I mean, you might think space travel is purely modern, right? Last century stuff. But this fascination, this dream of reaching the stars, it goes back thousands of years. What's the earliest sign of thing that we see?
Oh, you can trace it right back. Early civilizations. Think Babylonians, Egyptians, the Greeks. They weren't just using the stars for like navigation or calendars,
Yeah.
though that was important. No, they felt this deep, almost spiritual connection to it all. They saw patterns, gods, woven into their whole view of the world.
Right, and the myths they told. I mean, Icarus flying too close to the sun, okay, bad ending, sure, but it shows people were imagining it, right? What it might be like to actually leave Earth, soar up there.
It's this ancient longing, maybe for transcendence, you could say. And it wasn't just myths. Alongside all that, you had ancient astronomers, people like Hipparchus, Ptolemy. They were meticulously watching, charting planets, developing really complex models. Okay, the geocentric model turned out wrong, but for its time, revolutionary. They were laying down the scientific foundations, understanding how things moved up there centuries before anyone thought about actually going. Their records were crucial later on.
Okay, so we have that ancient curiosity, but how did that feeling, that sort of spiritual thing, start turning into something practical, something you could engineer? That seems to happen more around the 17th, 18th centuries, yeah, when science started giving it some real structure.
Precisely. The telescope.
Yeah.
That was the game changer. Suddenly, planets weren't just lights, they were worlds. You could see features, moons. And that just fired up the imagination again. Writers like Johannes Kepler, famous for his laws of planetary motion. He wrote this story, Somnium, kind of proto-science fiction about going to the moon. And he tried to use the science of his day to figure out how it might work.
And then, boom, Jules Verne, 1865, from the Earth to the moon. Okay, the giant cannon idea is, well, pretty wild by today's standards, but it was so detailed, it just grabbed people's imaginations worldwide, made them think, huh, maybe.
What's incredible about Verne is how he mixed the adventure with, well, the science he knew. He actually predicted things like weightlessness, the G-forces you'd feel, long before rockets were real. That kind of vision really inspired the next wave, the pioneers in the early 20th century. Konstantin Tsiolkovsky in Russia, Robert Goddard in the US, Hermann Oberth in Germany. These were the guys who started turning the physics theory into actual rockets.
And Tsiolkovsky had that amazing quote, didn't he? Earth is the cradle of humanity, but one cannot live in the cradle forever. He wasn't just dreaming, he was doing the math. Figuring out rocket equations, thinking about liquid fuel, multi-stage rockets.
Even space stations, decades before they happened, he really laid out a kind of blueprint.
So we've got the ancient dreams meeting the early science. But when did it really explode into this, global race? The Cold War seems like it wasn't just a push, it was almost a demand for speed, wasn't it?
Oh, absolutely. A total turning point. After World War II, you had all this rocket tech, originally for war, right, von Braun and others. Suddenly, that technology became the ultimate symbol, national power, science leadership. So when the Soviets launched Sputnik 1, October 4th, 1957, that wasn't just a satellite. It was this huge psychological blow, geopolitical statement. They were ahead. And for the U.S., yeah, it was a massive wake-up call, led to this incredible surge in funding for science, engineering, space.
It's maybe hard for us today to really get what that felt like, seeing Sputnik up there. Was the fear mostly military, or was it also just weird, knowing something man-made was circling overhead?
It was definitely a mix. Militarily, yes, the fear of missile capability was real, but philosophically, it really shook America. The Soviets beat them, challenged that whole idea of American tech dominance. You had people literally standing in their gardens, looking up, trying to spot this new little light. There was awe, for sure, but also this new feeling of maybe vulnerability. And so the race was truly on, driven by pride, strategy, and just this intense desire to achieve.
And just 4 years later, the Soviets did it again. Another massive step. First human in space.
Yep. April 12, 1961, Yuri Gagarin. He orbited in Vostok 1 for, 108 minutes? Seems short now, but it changed everything. His famous words, "Poekali, let's go." Yeah. That became the motto, didn't it? Symbol of just diving in.
Astonishing. And then just weeks later, Kennedy throws down the gauntlet. 1961. Land a man on the moon, bring him back safe before the decade's out. That was incredibly ambitious, almost a bluff.
It really was. I mean, consider it. The U.S. had only just managed a suborbital flight with Alan Shepard like a month before. Kennedy's goal seemed almost impossible then. But NASA? They stepped up. You had the Mercury program, proving humans could even survive space. Then Gemini, figuring out the tricky stuff, rendezvous, docking, spacewalks, all vital for the moonshot. And then Apollo. Apollo 11 launches July 20, 1969. Neil Armstrong, Buzz Aldrin, first steps on the moon.
And those words, that's one small step for man, one giant leap for mankind. It wasn't just about the achievement, was it? It was like, for a moment, the whole world was watching together, transcending Earth stuff.
A real psychological leap for everyone, I think. Proving we could do these huge things if we focused.
Okay, so that giant leap, huge moment, unified the world, fulfilled an ancient dream. But once the flags were planted, the question became, okay, now what? It shifted, didn't it? From just getting somewhere to actually staying there, learning to live and work in space long term.
Absolutely. The 70s brought the space station era. The U.S. had Skylab. Astronauts lived up there for months doing science, studying how space affects the body. And the Soviets had their Salyut stations, and later, Mir. Mir was really important, modular, long-lasting. It became this hub for international work, proving you could have a permanent base up there.
And leading, of course, to the International Space Station, the ISS launched in '98, people living there continuously since November 2000. That's just amazing, a symbol of global teamwork.
It really is incredible. Astronauts from all over, living together for months, sometimes years, doing really advanced experiments. And that research, it's not just for space. It helps us right here. Things like developing new drugs, protein crystals grow better in microgravity, advanced water filters, new materials, stuff that benefits all of us, often without us realizing it.
But it's not just humans up there. The robots have been just as crucial, maybe more so in some ways, going places we can't yet. Thinking of the Mars rover Spirit, Opportunity, Curiosity, just roaming around for years, sending back amazing data.
Oh, definitely. And don't forget the Voyagers, launched way back in '77. What's amazing is how they used gravity assists, slingshotting around planets to get the speed to eventually leave our solar system. Now they're out in interstellar space, Voyagers 1 and 2, our only probes sending back data from out there, telling us about the environment beyond the sun's influence. It's incredible. Humanity's reached out there through these incredibly tough little machines.
And then the telescopes, our eyes on the universe. Hubble, launched in 1990. It just completely changed how we saw everything. Galaxies, nebulae. Those images were stunning. Captured everyone's imagination.
And James Webb, JWST, has taken it even further, hasn't it, with its infrared vision. It's looking back at the very first galaxies forming after the Big Bang. Seeing the universe's baby pictures, essentially. Plus, analyzing exoplanet atmospheres. Looking for signs of habitability. Just mind-blowing stuff.
Okay, this next chapter feels really different, though. This new era with private companies, SpaceX, Blue Origin, Virgin Galactic. It's not just new rockets. It feels like a whole new way of thinking about space, right? Making it more accessible, maybe more daring.
It definitely is a shift. Space tourism is actually happening now. People paying for orbital views. But it's way more than tourism. These companies are pushing innovation incredibly fast. They're bringing launch costs way down. And they're planning really ambitious stuff. Moon bases, Mars missions, often working with NASA and other agencies too.
So what does that mean for the future? We're seriously talking Mars colonization now. NASA, SpaceX, others planning manned missions. Elon Musk talks about a self-sustaining city there in decades. I mean, that's huge.
It's absolutely monumental. And the challenges are enormous, let's be clear. You got intense radiation, both on the trip and on Mars itself. The effects of low gravity long-term, building life support that recycles everything, and just the psychology of being stuck in a small ship for 6-9 months each way. That's why NASA's Artemis program going back to the moon is so important. It's a test bed, practicing for Mars, basically.
And looking even further out, the ideas get even wilder. Asteroid mining, building huge habitats in orbit, and things like breakthrough starshot, sending tiny probes to other stars using lasers. The ambition is just, wow.
Yeah, interstellar travel for humans is still way off, very theoretical.
Yeah.
But starshot, That's fascinating. Tiny light sail probes pushed by powerful lasers from Earth. They could potentially reach Alpha Centauri, our nearest neighbor system, in maybe 20 or 30 years. That's incredibly fast compared to rockets. Could give us our first close-up look at planets around another star.
And technology like AI and quantum computing are playing a bigger role too, aren't they?
Oh, massively. AI is already vital. Rovers on Mars making their own decisions about where to go, what to analyze. Satellites using AI to process huge amounts of data instantly, faster than humans ever could. And imagine quantum computing down the line. Its power to handle incredibly complex problems. It could revolutionize how we plan trajectories for deep space missions, finding optimal paths we can't even calculate now, or enable super secure communications over vast distances. It's about making things possible that seem impossible today.
Which naturally brings us back to that ultimate question. The biggest one humans ask, maybe, are we alone?
It's the question that drives so much of this, isn't it? For centuries. I mean, statistically,
Hmm.
billions of stars just in our galaxy, likely billions of planets. It feels improbable that Earth is unique. You've got projects like SETI listening for signals, and our telescopes finding thousands of exoplanets, many in that habitable zone where conditions might be right for liquid water, maybe life.
Imagine finding something, anything, even microbes. It would just change everything. Our view of biology, evolution, our whole place in the universe.
Redefine life itself, potentially, challenge core beliefs,
Mhm.
and connecting that to the bigger picture.
Hmm.
We have to think hard about our role out there. Are we explorers? Are we colonizers? Just observers? We're gaining incredible power, the ability to potentially terraform planets, change whole worlds, mount asteroids, but with that power comes, well, huge responsibility.
Yeah, the ethical questions are massive. Like, if Mars does have some kind of simple life, microbes maybe, do we have the right to go there and risk contaminating it with Earth life, wiping it out before we even understand it?
How do you even balance exploration with protecting what might already be there? It's a really tough dilemma. We need clear rules, ethical guidelines. We have to act like stewards, not just conquerors. And maybe that's the most valuable thing space exploration gives us, that perspective. Astronauts talk about the overview effect, right? Seeing Earth from space. This tiny, fragile blue marble. It brings the sense of connection, unity, fragility, teaches humility, maybe, cooperation, the need to protect this home we have.
So just to kind of wrap up our journey here, we've gone from the earliest human sky gazing through early rockets, the huge leaps of the space race, the moon landing, then living in space on stations, the amazing work of robotic probes, and now this future driven by new tech and private companies.
And we've touched on those really deep questions too. The search for life, our responsibilities out there. When you zoom out, space exploration, it's not just science, is it? It's fundamentally a human story. It's fueled by curiosity, courage, and just this incredible imagination that won't stay put on one planet.
Yeah, it's a story about what it means to be human now, and maybe what it could mean to become, well, multiplanetary.
So thinking about that, here's something for you, the listener, to ponder. If we are going out there to explore, maybe even settle other worlds, how does the definition of humanity itself change as we adapt to totally different environments? What does it mean for our cultures, our societies, our identity, when home isn't just Earth anymore, but maybe several worlds scattered across space?
Lots to think about. Until next time, keep looking up, stay curious, and keep exploring all the potential, both within us and out there beyond our planet.